Okay, standard disclaimer. I am not a machinist, gunsmith, or welder, so probably doing this bass-ackwards and completely wrong, so don't try this. Today I have a Page-Lews Arms Model D single-shot bolt-action 22 rifle. Thinking around 1920-ish vintage. Picked this one up, some obvious damage, starting with the most difficult to repair part first in case things go bad. I don't waste a bunch of time on parts I can't use. So this is the receiver off the rifle, and as you can see right here, the receiver is cracked all the way through. There's also a stress fracture right back here starting to form that it's about 3/4 of the way to breaking out the back. The good news is, with a little bit of pressure, the crack just seals right up. So I'm hoping with a little welding, machining, and effort, I can get this thing back into shooting condition. So first up, I'm going to go send this thing through the parts washer and make sure there's no other surprises hidden under the little bit of gunk that's still left on here. And here we are at my high-tech cleaning bench. Nothing but premium tools here. And that should do that. So far, don't see anything other than those initial two cracks. So hopefully this will be a pretty straightforward and easy repair, but haven't done it before, so first time for everything. And that's a project for another set of videos. Okay, while I'm up here, I'm going to find myself a piece of steel to make a mandrel for this. So, my lovely collection of random steel bits and rods. Well, that's a pretty good fit. I don't even have to turn it. What I'm looking for is something that basically is a perfect slide fit. You know, almost pressed on, but not really. Because then I'm going to clamp this against this rod before I weld it. So I think I am going to use this piece of steel rod. It's a little bit loose. I really would like something a little tighter. Because the other plan is, once I do get this all trued up, I'm going to throw this into my lathe to turn the outside back around where I weld it. So the tighter the fit, the better that's going to be. Yeah, that's too loose. I'm going to have to turn this custom one. So go one size larger and lop off a piece about yay long. More work, but it should turn out with a better finished product if I get it exactly centered in the lathe. Okay, I'm just gonna quick lop off a chunk of steel here. Don't need to be exact or fancy, you just need it shorter. And there you have that. So with that, head back downstairs and first off throw that in the lathe and make it so it's a slip fit with respect to the receiver. Well, sorry about that. I got set up and going and then realized that for some odd reason my camera didn't start recording, so we lost most of the setup on this, but not too exciting. Basically, took my round stock here and mounted it into my chuck, center drilled the end such that I could support it with a live center. Due to the fact that this piece is so long, I'm afraid that it could get out of whack and really do some damage. Other than that, I started turning the outside diameter, which isn't uber exciting, but in fact, it's really not exciting. So I'm going to continue on with this until I've reduced the diameter of that rod there to just slightly under this diameter, so I can slide this on and not have it jiggle around at all. That's going to take quite a bit, and sort of want to save the batteries on my camera, so I'll probably cut out here and come back once I get, you know, close to diameter, and I can show you how I measure it up and set up my DRO to hone in or zoom in on the final size. Okay, I thought I'd show you quick how I set up my DRO. So I've made a skim cut the entire length of this part, or this steel rod, and I just turned off the mill and haven't touched anything. First off, make sure that I have enough metal, and that should be plenty long enough. Next, I'm going to zero out my Z-axis so I can watch this and know exactly when I'm getting to the shoulder. So I can stop a little bit close and manually run it in so I don't keep double cutting. Next up, I'm going to measure the diameter of this skim cut using a micrometer here. Directly across sometimes can be a little tricky. So in this case, we're .6567779. Preset X, 0.6567779. Okay, just double check my value in another spot, and then I should be good to go. And this time I got I think I misread this. Crap. Okay, next up, like I was saying, okay, 0.6567, so 0.607, and the next digit would be 4. Okay, check it one more spot just to make sure I get about the same reading. So 0.65, 0.605.
As well as careers in research, health sciences, and the the bioscience industry. Visit
5.1.
bar.umn.edu/bshs.
I'm going to go with 0.605. That will be close enough.
Enjoy holiday shopping like never before at Apache Mall with a distinct selection of
So now, if I unlock my cross slide, back her off, disengage this, back her off. You can see parts approximately a little under 5 inches long, and I have a long ways to go. So I'm going to sit here and keep turning it down until I get to
It's the answer for all your wedding dance questions. KROC Music on Wheels disc jockeys. Go to the web at Music on Wheels.
so 510-ish is where I want to get to, 510, 5.8. So I'm going to take it down to 525, and then I'll come back
And be the life of your party. Call KROC Music on Wheels disc jockeys.
and we'll go from there.
2000.
Now, the proper way to measure this would be to use an inside feeler and then measure the feeler with a micrometer. Unfortunately, my inside feeler set splits right at 1/2 inch. The smaller than a 1/2 inch one is too small to measure this, and the bigger than a 1/2 inch, when it's compressed that far down, it doesn't cleanly touch the edges. It's like the corners on the pistons touch. So that's a real pain to measure, and you know, I can slip fit and feel this for the final fit, so I'm not going to worry about it this time.